Sarah? Hi, Sarah.
Hi.
How are you? How was your holiday?
It was good. How was yours?
Good. So, you must not have had very much, just have one day of math class?
Yep, and one thing to go over.
Okay. What do we got?
Okay. So it's solving, I don't know what you'd call it, I guess. Solving word problems or story situations or whatever the hell they're called. Writing quadratic equations and functions.
Okay.
And then he wants us to solve it by graphing it on the calculator.
Okay.
Alright. So I guess just do a couple of these.
Uh-huh.
Alright, the first problem says, the sum of two numbers is 20. If one number is x, excuse me, then the other number is blank. Their product is, it has a blank. It wants you to fill in.
Okay.
And then their product is a function of x. Find the minimum value of y, or of the function.
The sum of two numbers. Okay. So x is one number. What should we let the other number be?
20 minus x.
Yeah. So that's equal to the first number, and that's equal to the other number. Now what does it say about the product?
It wants you to find what the product, so then you say the product is equal to y, and it wants you to find the maximum value that it could be.
Okay.
Alright, and then I think you just plug it in. This one was easy. You just plug it into the calculator, right, to graph it?
Yeah, y equal x minus x squared plus 20x.
This is dumb and hard.
Okay, so let me graph it on my calculator here so that we can see it. I'll graph it on Wolfram Alpha. You're using your Inspire?
Yeah.
So does yours look something like that?
It's still, I can't see your graph right now.
You can't see my graph.
Nope.
No?
Oh yeah, there it goes. Yeah, it was loading. It's giving me the spinning.
Okay. So does yours look something like that?
Yeah.
Okay. So what is the maximum, what did they want to know? The maximum value for this function?
Yeah.
Okay. What is it?
I get that the vertex is 10, 100.
Yep.
So, and your maximum y value would be 100?
100. Uh-huh. Okay. So in other words, the maximum y is the y coordinate of the vertex. So we could do that a couple of ways. We could use minus b over 2a to solve for where the x coordinate is. Oh, she wanted you to do it in your calculator anyway, using the max function, huh?
Yeah.
All right. What else do we got?
And some more difficult ones. Okay. There are currently 20 members in a school ski club, and the fees are $8 per member. To encourage the recruiting of new members, the club treasurer suggests that for each new member recruited, the dues for all members be reduced by 10 cents. So the first question is, wait till I finish writing. So the first question is, how much money will the club have if it recruits 10 new members, 15 new members, and N new members?
Okay. So.
And then for what value? Oh, sorry.
That's all right. So what's the function that tells us what the total revenue of the club is? Well, let's figure it out piecemeal. If we recruit 10 new members, what is our revenue going to be?
$80, but then...
No, it's going to be $80 from those 10 new members, but we've got 20 other members, 10 of whom must have referred new members, so who are going to get a reduced rate. So if I wanted my revenue function, what would it equal here?
80 times 10 minus 0.10 of the remaining of the original members?
Well, how about if we recruit 10 new members, how many members are we going to have?
30.
So I could write 30 times 8 minus 10 times 0.1. Because 10 of those 30 members are going to get a reduced discount of 10 cents. So they'll only be paying $7.90. I also could have written that as 20 minus 10, in other words, this number minus this number. That number of people will pay $8. Plus 10, the number of people that made referrals, will pay $7.90. Plus the 10 new members would pay $8. So those two functions would both represent the revenue functions.
Okay.
Okay, the first one's pretty easy to do with 10 new members. So if I say that's X, then I really can write the revenue function as 20 minus X, right? Times 8 plus X times 790 plus X times 8.
Okay.
In other words, in the first case where X was 10, there's my 10, there's my 10, and there's my 10. So let's erase this one. We don't want that one. So our revenue function looks like this when expressed as a variable. Let's see if that makes sense. Let's say we recruited 20 new members. So how many people pay this $8 right here?
20.
None.
Well, not that. Okay, so 0 people pay that $8.
Right. And then you would have 20 people that pay $7.90. And then you would have 20 people that you recruited that each pay $8.
Okay.
Okay? So this, I can add 7.9 times X and 8 times X. So this revenue function can be simplified a little bit. In fact, I can multiply these two out. So I got 160 minus 8x plus, what is that, 15.9x? So that should be our revenue function. Did I miss something here? This doesn't have to be a quadratic, does it?
I don't think so.
Okay, so they wanted to know what the revenue was for 10 people. So let's figure that out. So R of X, so R of 10 is equal to what? 80, well, I can even simplify this. Ew, that's weird. Yeah, it just becomes 7.9. So when X is 10, I make $79 plus $160, I make $239. So when we just had 20 members and we were getting $8 per member, we were making $160. So this number makes sense.
Okay.
Let's go back and make sure that number makes sense by doing it the first way we did it. If we have 10 people making a referral, then we'll have 10 members paying $7.90. We will have 10 members paying $8, and we will have 20 new members paying $8. So that's 160, that's 80, and that's 79. 240 plus 79. We only recruited 10 new members, not 20.
Yeah.
So that's only 80. So that gives us 239.
Okay.
So our revenue function appears to be correct. Okay? In other words, when we take a specific number and work through what we know to be correct, it fits this revenue function right here. 160 plus 7.9x. So what was the second part of this question?
For what value of n will the club's total membership money be a maximum?
M is the number of new members recruited?
Yes.
This has got to be a quadratic, because this thing doesn't have a maximum.
Yeah, well...
In other words, x being... Okay, let's go back and redefine our revenue function here. X, I said, was the number of new members recruited. That's not really correct, is it? Because that would mean the most we could have is 20.
So...
Read this problem from the start again, if you would.
Alright, okay. Oh, goodness. There are currently 20 members in the school ski club, and the dues are $8 per member.
Okay.
To encourage the recruiting of new members, the club treasurer suggests that for each new member recruited, the dues of all members be reduced by 10 cents.
Oh.
This is, okay, wait.
So why is 1 million new members not the answer? Or 1 billion? What prevents us from recruiting 1 million new members?
Because you're taking all the dues down by 10 cents, so if you take, like,
It would end up being
800
zero.
members, you don't have
Okay.
any money left.
Okay. So we can't raise any more than 800 members. Okay, I think I get it now. This is not the revenue function. The revenue function, let's see, if I let M equal total members?
Yeah, so, let me think.
So they're saying what value of M represents the maximum revenue?
Yeah.
Okay.
And then,
so we need to come up with something that's going to be a quadratic because that will have a maximum. In other words, what I came up with at first was just a linear function. That doesn't have any maximum. X can be 1,000,000 or 1,000,000,000 and it increases revenue. So there's something wrong with that. So let's see. This isn't a linear programming problem, is it?
Nope. This should be a quadratic.
Okay. So let's figure out if we can put this quadratic together. Let's see. So the total dues are going to be the total members times each member's dues.
Okay.
What if we let M be the total new members?
Yeah, and then you could add it to the original 20.
So our dues are going to be 20 plus M times $8 minus M times 0.1. Does that make sense?
Vaguely. Because you have the original 8 minus the amount of new members.
Okay, so if we had 10 new members, that's right, isn't it? No. If we had 10 new members, everybody's membership is reduced by 10 cents, right? So our membership with 10 new members would be 30 times 7.7. For every new member, the membership fee is reduced by 10 cents?
Yeah, it says the dues are reduced for all members.
By 10 cents per new member?
Yeah.
Well, this will produce a quadratic. So the total revenue will be 20 plus the number of new members, and each one of them will pay not $8, but $8 minus the total number of new members times 0.1. I believe that makes sense. And that will produce a quadratic that opens down. So when we FOIL these out, we get minus 0.1 m squared plus 8m minus 2m plus 6m plus 160. I believe that might be our quadratic. Notice that if m is 0 and there's no new members, the total dues are 160. All right, this looks right. So R of 10,
oh, my pen's broken. 1 second. Technical issues. Okay. So if R is 10, then you have 30.
if M is 10.
If M is 10, yeah, then you have. Wait, you want M to be 10?
Yeah, M is the total new members.
All right. And then.
So if we have 10 new members, that was the first part of the question, right? How much is the revenue with 10 new members?
210? No. Yes?
Well, plug in 10 for M.
Yeah.
Looks like 210. Now, let's see if that makes sense. So we have 30 members, and every member is going to pay $7, right?
Yeah.
Because there were 10 new members, so every member got his dues reduced by 10 times a dime or a dollar. So that seems right. Okay, and after the R of 10 was, where is the maximum?
One second.
Plot that on your calculator and figure out where the maximum is.
I'm doing it. The window is fighting me.
Okay.
Okay.
And we need the x coordinate and the y coordinate of that maximum.
Okay.
The x coordinate will be the number of new members.
I can't. Okay, sorry. Struggling with the calculator.
Well, that's good. That's, in other words, she may want you to do this on a calculator, so you need to figure out how to get that window so that you can find the maximum.
Yeah.
Remember, the only thing you need in your window is that vertex.
I'm trying to adjust my window, but I gave up and just zoomed out instead because that was...
Okay.
So it's a maximum value, right?
Yeah.
That would be the...
Now, it should give you an x and a y coordinate for that maximum value, for that vertex.
Yeah, it gives me 30 for x and 250 for y.
Okay. So if we get 30 new members, we'll have a total of $250 revenue. Notice that if we got 31, we would reduce our revenue. If we take R of 31, that revenue goes down, as you can see on your chart. Let me plot that chart on Wolfram Alpha here. Let's see, that is minus 0.1 plus 6 plus 160. Okay, 30 looks right, and 250 looks right. In fact, I bet Wolfram Alpha gives it that information to us. Let's see. No, it doesn't. It doesn't tell us that maximum. Guess you got to pay extra for that version. Okay.
All right. Okay.
All right. Well, that actually is a pretty good problem, because it shows you that, you know, maximum new members don't increase revenue. A certain number is optimum.
Yeah, because especially if you keep reducing your revenue every time.
Right.
Okay. I have like 10 pencils and I keep losing them everywhere. Okay. So should we do another problem like that one?
Sure.
That'd be interesting. Okay. A charter company will provide a plane for a fare of $60 each for 20 or fewer passengers.
Okay.
Each passenger in excess of 20, the fares decreased by $2 per person for everyone. What number of passengers will produce the greatest revenue for the company?
Okay.
Alright, so they start.
Well, this is the same as the last problem, isn't it?
Yes. Similar.
Okay. So I think our formula is going to be the same thing. It's going to be that. Let's see if that makes sense. Our total revenue as a function of the number of total passengers. Well, let's let X be the number in excess of 20.
Okay, so X is people over 20?
Yeah. Notice the same thing on the previous problem. M was the number of new members, not the total members. So X is going to be the amount in excess of 20. So we're going to have 20 plus X is going to be our total number of passengers. And we're going to multiply that by 60 minus the total number of new passengers times 2. Same thing we did up here. So if X is 0, we just get 20 times 60, right?
Yeah.
Okay. Let's just check one more number. If X were 1, we would have 21 passengers, and everybody would pay $58, right?
Yeah.
What's 21 times 58? Well, we can see that that's what we're going to get here. If we let X be equal 1, we're going to get 21 times 58. So this function looks right. The key to both of these last two problems was not to let your variable be the total number of passengers. You want your variable to be the total number of passengers in excess of this base.
So it's like you find your base first, and then X is the extra after your original amount?
In other words, in the previous problem, we let M be the number of new members, not the total number of members, but the number of new members. Now, is it obvious that 20, in other words, anything less than 20 can't maximize revenue?
Yeah.
Yeah, I think it is. Obviously, 19 gives you less revenue. Any number less than 20 gives you less revenue than 20. So there's no way X is negative. So this works. So let's turn this into a quadratic and find the maximum of it.
Okay.
Multiply these two together. What quadratic do I get?
Oh, my freaking pen. Okay, you get... Could you make this, could you make the X times 2 just be 2X? That won't change anything, will it? Okay.
Yeah, no, that's right.
So 2X squared.
Minus 2X squared.
Sorry, minus 2X squared. Plus... Plus, where am I forgetting my... Oh, there I am. Okay. My plus 20X. Plus 120?
1,200.
Oh, sorry.
2 times 6 is 12, and then we have 2 zeros.
Yeah.
So put that into your calculator and find the coordinates for the maximum.
Oh, it's giving me the thing. The E thing. What did I do? Okay. Questions about the calculator.
Okay.
So it gives me 5 for the X value.
Okay, so that means 5 new passengers create a maximum.
Yeah. But then for the Y value...
What does it give you for the Y value?
1.25, and then it has that little capital E symbol, plus 3.
That means times 10 to the third.
All right.
Okay? So that would be, move that decimal point 3 spots, 1, 2, 3, and you get $1,250 is the revenue. And X was what? 5?
5.
So there's a total of 65 passengers. And each passenger is going to pay how much?
Passenger will pay. Well, you subtract 2 for each extra. So you have 60 minus 10, right? Which would be 50.
So what does each passenger pay?
$50.
So we have 65 times 50. Is that $12.50?
I think so.
No, I don't think it is.
65 times 50? 65 times 50?
Yeah.
Would be 3,200.
Oh, it's not 65 times 50, it's 25.
Yeah.
Yeah, each passenger pays $50 and there was only 5 new passengers. So 25 times 50 is $12.50. In other words, I wanted to make sure our answer made sense. And you can see why more passengers don't increase revenue, because this one is being squared. So as soon as x gets large, we're really subtracting a lot from revenue. We're still adding this amount here, but remember the higher degree polynomial makes the most difference when evaluating end behavior. So this minus 2 tells us we're looking at a parabola like that. So whatever that value is, and the one you gave makes a lot of sense. In other words, this airline actually increases their revenue by taking on additional passengers and offering them a discount. But they wouldn't want to make that deal and have 100 people sign up more. Their plane couldn't hold it. But their plane can hold an additional 5 passengers. And 5 more passengers increase their revenue by quite a bit, by $50. Because otherwise it would have been $1,200 if they just took 20 people.
Okay, 1 second. I'm going to look at my problems. Okay, so what if, one of the problems farther down the page, which, is kind of the reverse. Like for when you increase the fare, you lose, like, passengers or members.
Okay. All right, let's do that problem. We got time.
Okay. A ferry service transporting passengers to an island charges a fare of $10 and carries 300 persons per day.
Okay.
The manager estimates that the company will lose 15 passengers for each increase of $1 in the fare. Find the fare that yields the greatest income.
Okay. The ferry holds 40 people that they charge $10 each. And
No, the ferry holds 300 people, I believe.
Where'd the 40 number come from?
The 40?
Uh-huh.
Wait, 40? Oh, I don't know. That's
300 times $10 each. Okay.
yeah. And then for every $1 it goes up, they lose 15 people.
Okay. So, let's see. Our revenue function, what are we going to let the variable be? In the same line of thinking.
Alright, so 300 people is, yeah, minus x?
We're going to let x be the number of people less than 300. In other words, if x is 1, then the ferry is going to take 299 people. If X is 10, the ferry will take 290 people. You with me?
Yeah. It's
Okay.
like the reverse, right?
So the total number of people that we're going to transport is going to be 300 minus X. There's one factor. Right?
Yeah. And then for the
What
other
is
part,
each one of them going to pay?
they're going to pay $10 minus X.
Ooh, we lose $1 each for every 15 passengers?
Yeah.
Oh, man. Let's let X be the numbers of,
Groups of 15?
yeah, less than 300. Does that do it? Let's see what happens if we try that. There may be a better way to write that, but number of groups of 15 less than 300. In other words, if X were 1, we would be taking 285 people. So
Why would it be?
let's just go back and change that to the number of people less than 300. And then the total number of people are going to be 300 minus X. Let me think for a moment. Each one of them are going to pay what?
They're gonna pay.
If for every 15 passengers they charge more, $1 more.
Okay.
For every 15 passengers less than 300, they charge $1 more.
Yeah. So, 300. Frick. Okay.
Okay, so it would be 10 plus X divided by 15 times 1. Does that make sense? Let's see.
Yeah.
If X were 15,
Yeah.
exactly, then we would have 285 customers, and they would pay $11 each, correct?
Yeah.
And X is 15, so that would come out exactly what this would be. Now, let's say X is 30. Then there would be 270 passengers, and each one of them would pay $12 each.
Oh, my thing is over at 6:45, so I can get up. Okay. Sorry. Okay, my mom is wondering if after we're done with this problem, if I can switch out for David for the...
Oh, sure. Well, we only have like 20 minutes left.
Yeah. Yeah. And then she'll pay you for whatever extra, because David's...
Yeah, no, that's fine. It's just I have another appointment, so I can't go.
Alright,
but I can certainly do that, yeah.
okay, I think I have this problem, so...
Yeah, I think this is the right revenue formula.
Alright.
And notice that if X was only 1, that's where it gets sticky, is they don't really say what happens if you get just one extra customer, or rather one less customer. Does everybody still pay $10, or does everybody pay $10.10 approximately?
All right.
For every 15 passengers, they increase it by $1. Does that mean if there's only 14 passengers less, they keep charging $10, or they charge a fractional amount?
Well, I guess because you graph it, since it's the vertex.
Uh-huh.
I don't know if it'll...
Well, go ahead and graph it. Go ahead and put in your y as that rather than, don't worry about multiplying it together. Just put in y is 300 minus x times 10 plus x over 15.
Okay.
Figure out where that maximum ends up being.
Okay, x divided by 15. Okay. Window.
So actually the function that you should be plotting is minus x squared over 15 plus 10x plus 3,000. Graph that function and find its vertex, or its maximum.
So then, 75 for x, and then 3.38 times 10 to the third.
3.380, so $3,380.
Yeah.
Notice that that's more money than if the boat is full. If the boat is full, they get 300 times 10, 3,000. So they actually do better with a boat that only has 225 people on it. Because for 225 people, that's 5 groups of 15. So they're going to charge everybody $15, and that's where you get $3,380 in revenue.
Okay. Yeah.
So that might be the correct formula. I'm not quite sure how they're handling partials. In other words, what would happen if only 5 passengers less? What would they charge each passenger? Would it still be 10 or would it be 11?
I'll ask my teacher tomorrow.
Yeah, it's not real clear. Because I'm not sure this answers it for partials properly. In other words, if we had a partial x that was not a multiple of 15, we're going to get an answer that's not a round number. And that may or may not be allowed. So, all right. You want to have David come on?
Yep, I'll go grab him.
Okay.
Apparently the homework is challenging tonight for him.
Okay.
All right, thank you.
Uh-huh.
Yeah. So just pay attention to him. Hi.
Hi, David. How are you?
Okay.
Yeah? So you got some extra hard problems tonight?
Yeah.
Okay, that'll be new. What do we got?
So the first one is we have to find, fill in the missing dimensions.
Okay.
And then, so, actually,
You want me to go to that site?
it's not on the site.
Oh, okay. So go ahead and read it.
Scale factor for a model is 8 centimeters each.
Now, how come all of a sudden it's choppy?
I don't know.
You using exactly the same setup that Sarah just used?
Yeah.
Maybe it's my hearing. I'm sorry. Go ahead and talk again. I'll try to listen more focused.
The scale factor for a model is 8 centimeters. equals blank meters. The model is
8 centimeters equals what? Oh, equals blank?
yeah.
Okay.
And then the model is 30.5 centimeters, and the actual thing is 70.6 centimeters.
So we could say 30.5 is to what? The actual thing is what?
70.6
70.6?
meters. Yeah.
So
And
we
then,
have 30.5 centimeters represents 70.6 meters, right?
yeah.
Okay.
And then so I couldn't find out how to solve it.
Okay. Let's do it 1 to 1. Let's make one of these the other. Let's convert meters to centimeters since our answer desires everything to be centimeters.
The blank is in meters.
Oh, okay. Well, let's not reduce it then.
Yeah.
So, in other words, it's this problem here, isn't it?
Yeah.
Just have a ratio equals this ratio. Solve that for x.
Yeah.
How do you solve that for x?
So
What's the first thing?
So the first thing you do is you have to put the variables on one side and the non-variables on the other.
When you have a fraction equals another fraction, always think cross-multiply as your first step. Multiply those two equals the product of those two. So I have 30.5x, units on it are centimeters, meters, equals 8 times that. What's 8 times 7, 70.6? Do you have your calculator there? Might as well use your calculator because we don't have a lot of time here.
So 70.6. 564.8.
564.8, also centimeters, meters. So x, if we divide both sides by 30.5 centimeters, meters, x ends up being this.
Well, couldn't you just... Oh, wait, no, you're right. Never mind. Oh.
So what is that number? 564.8 divided by 30.5.
Doing that. And divided by 30.5. 18.51-ish, and we only have to round it to the nearest 10.
So 18.5. So now let's look at this picture and see if it makes sense. Always add that last step. Okay? So 8 centimeters is about a fourth of that, right?
Yeah.
And this number is about a fourth of that. So everything looks copacetic. It looks right. In other words, we're not off by a factor of 10. We didn't come up with an answer of 185 meters, which wouldn't make sense. 1.85 meters wouldn't make sense. So it looks like we're correct. Now, I do have my doubts as to whether or not we need to convert this to centimeters before we do anything. But not really. Because notice that to convert this to centimeters, I multiply it by 100. I do the same thing over here. And then I get my final answer. I divide it by 100 to get back to meters. So it's okay to work in multiple units with this.
Okay, so the next one is the scale of a map is 7 meters to 14 miles.
and then the map is 14 meters equals blank miles. This one's easy.
Okay, what is the answer?
So, 1 sec. Well, 7. Wait, no. No, 1 second, let me write it down. Well, I know that 7 by 2 equals 14.
Okay.
So 14 by 2 equals 28.
There's your answer. Make sense? Yeah. This is twice what this is, so this has to be twice what that is.
Okay.
Okay?
The next one is the scale of a map is 8 kilometers equals 16 miles. Over, 6 miles. And then it is blank kilometers over 50.2 miles.
50.2?
Yep.
Okay, now this one is particularly easy to solve. How do you solve this? This is the one exception to where you would automatically cross multiply. What do we need to do to solve this? We don't need to cross multiply. What do we need? We're trying to solve for x.
Reduce?
How about if we just multiply both sides by this denominator?
Oh yeah, because x is...
That'll leave x all alone. So we get x equals 8 times 50.2 divided by 6. Now reduce. But notice that it would have been an extra 2 steps had I cross multiplied, because I would have had this equals 6x, and then I would have had to divide both sides by 6 to get to this same step. So you don't always cross multiply. If your variable's in the numerator, you only need to multiply both sides by the denominator. Okay? So you can get this answer in any number of ways. I can simplify it. When I go to reduce this, what would I write instead of 8 over 6?
401.6 over 6. And then she doesn't like decimals in our fractions. So, wait, no. Oh, yeah, so she doesn't like decimals, so it would be 416 over 60.
Okay. Over 60 or over 6?
Over 60, because you would need the decimal point. Okay. I see. Because you can...
What's that number there? Do that number in your calculator.
So, okay, 1 second. I see. So, 50.2 times 4 equals 200.8.
And then divide it by 3. You see why you divide it by 3?
Yeah, because there's...
Because I reduced this to 4 over 3.
Mm-hmm.
Okay. So what is x?
Let me do 200 divided by 200.8 divided by 3 equals 66.9.
Kilometers.
Yeah.
Does that figure make sense?
Yep.
Yeah, because the 50 is almost 10 times bigger than 6, so this should be almost 10 times bigger than that.
Mm-hmm.
Okay?
So, the next one is factor for a model is 10 centimeters over x meters, and it equals 80.2 centimeters over 40.2 meters.
40.2?
Yep.
Okay. How are you going to solve this equation? What's our first step?
So you cross multiply.
Okay.
You get
So we got 80.2x equals 402. Now what?
And then you divide by 402 on both, no, by 8.
80.2.
And then
Should
you
be
divide.
approximately 5.
You get, yeah, pretty much 5 if we're rounding to the nearest 10.
5.0?
Yep, 5.0124.
Okay.
Somewhere in that area.
Yeah, so these are all the same. These are all just ratio problems.
Yeah.
They're no different than what we did last time, I believe. Just harder to set up.
Yeah.
In other words, the whole deal is taking those scale factors and turning a 5-to-1 scale factor into 5-to-1. Whether it's 5 inches per mile, then if you measure 15 inches on a map, that better be 3 miles.
Yeah.
Always maintain that ratio, 5-to-1. Even for different units. We don't care that it's different units. And that's usually the way it is. A map. The scale factor will be inches per mile. It won't be inches per inch or inches per kilometers usually. It'll be some small amount because a map is greatly reduced.
Yeah.
So your units are usually going to be different, not the same.
So you have to go now, right? Because it's been...
Yeah. No, this is about... I got to get ready for my next session. Unless you have any emergency last questions.
Nope.
Got it, you think?
Yeah.
All right. Sounds good. I will speak with Sarah at 3:30 on Wednesday, and I'll see you at 4:30 on Wednesday.
Okay.
Okay?
Yep.
All right, David. Have a good one. Bye-bye.
Bye.